Can we start? I hope we're live now. Okay, hi everyone, and welcome to the topic custom bindings for Azure Functions. This is a more advanced topic. This time, I hope everyone hears me fine. And we will go a bit deeper into Azure Functions and how you can use custom bindings to bind your own data sources and data sinks to use them in Azure Functions. My name is Sia Ghassemi. I am an Azure MVP and I work a lot with functions. And I'm happy to present here at CloudGen 2021. And I'm looking forward to your questions after the talk. Usually, I tend to have a lot of demos and a lot of code. Because of the short time of 1 hour, I'll try to make as much demos as possible. But if you have questions afterwards, you can always reach out to me over Twitter or look up my code on GitHub, however you feel best. So let's get to the topic right away. So the Azure Functions architecture is based around bindings. We will talk into the architecture, we will talk about bindings, how the bindings work. We will make up an idea for a custom binding, and then I will demo this, how it would look like if we implement it. First of all, let's talk about the architecture. So Azure Function consists of different things that are basically the host runtime, the triggers, the bindings, input and output bindings, and different than AWS Lambdas or Google Cloud Functions. The bindings are the thing that difference serverless functions on the Azure side from the counterparts. The concept is basically like this. Whenever a trigger comes in, it goes to the host runtime. The host runtime looks up the input bindings, reaches out, loads the data, and then uses gRPC to send them down to the runner. When we're talking about the Node runner or the Python runner, PowerShell runner, the communication there is gRPC. For the .NET runner, as of now, there is an in-proc, so it's running inside the host runtime process. But there is right now an GitHub issue, a GitHub source that is creating an out-of-proc .NET runner too. So in the future, the same will happen there. So after the host runtime has loaded all the data from the data sources that are part of the input bindings, the data and the data that is coming in through the trigger is serialized to the runner. The runner executes the function, and then whatever is part of the output bindings is serialized back to the host runtime, and the host runtime talks to the data sinks to write the outputs. After that is done, the function completes and everything is fine. As I said, there are two different types of bindings. We have input bindings and output bindings. Input bindings usually use an interface that's called iConverter or iAsync converter. For output bindings, we have the collector or the iAsync collector. There's both. And then we have some parts for validation. So we can say when null, use this binder, or when not null, use this binder. So we have some kind of validation we can do there for our bindings. So how it works is that Azure Functions allows you, or the host runtime, which is basically WebJobs runtime, allows you to add converters too, so that you don't have to create bindings or binders for every type that you want to support. So usually you just create one type that you want to support. And then if you want to support other types, you basically use converters. One possible way to do this, or one example of when we do this is, let's say you have a type, this is your custom type, but you also want to support the JSON string, because it is coming over HTTP and you only have the JSON string and you don't want to deserialize it yourself. You can create a converter from string to your type, and then the converter is run. After that, your binder is called to do the actual action. On the other hand, there's also something that is called an open converter. An open converter allows you to support custom types of the user. So if the user of the function, so when someone is using your binding and they want to support whatever their type is, you can support that by adding an open converter. An open converter then needs to convert from whatever user type there is to your type. We'll see that in the demo too. You can do a lot of things, some serialization and deserialization and things like that. There are a few things that you can do. So to support user-defined types at runtime, as I said, you need to support a converter or add a converter that is where you don't specify the T, because this is coming at runtime. And the binding rule, when you create a binding rule, you need that type T. Yeah, and then from that we can use the open type to go forth and back. So for the demo, let's look at custom binding that, for example, supports SQLite. So let's imagine you have some data in a SQLite database and you want to grab some data from there or write some data from there. So we'll start from there and then add all those things that are needed. Because it's hard to start from scratch if you don't know where to start. On my GitHub, you will find a template, which is basically giving you a lot of things, and you just need to replace all the parts that are needed there. So let's jump into the demo. Okay, so here I have the SQLite binding extension, as you can see, and there's not much in there. So if we look at the project on the Firebase, I have a source folder. Oh, let's do it maybe it's a bit better to see then. So we have source folder, and in there we have different folders that are called bindings, configs, and so on and so forth. We will see that in Visual Studio. But as you can see, this is just a regular C# project. Oh yeah, maybe that's important to know. Sorry for that. Bindings need to be written in .NET. You can't write bindings in JavaScript or Python or whatever. They need to be written in .NET because they're running on the host runtime, and the host runtime is .NET based. So if we open this up in Visual Studio, then you can see we have the folder structure here on the site. We have our bindings, we have our config, the converters, and our attribute. The attribute is the most important part, and as you can see in the attribute here, let's go to 200. You have this attribute set on the attribute that says binding. This way Azure Functions knows that this is a binding and can be used. In the attribute you add configuration like connection string or whatever. If you have worked with Azure Functions, you know that there's usually a function.json that describes how the binding is used, if it is an input or output binding, and what are the different types that you need to have there to support this. And basically what you do is you put all the configuration in here. If you add the attribute app settings to a configuration property, then this means for Azure Functions to go to the app settings in the function app to load the data from there. And then this property needs to have the name of the attribute. I'll show you that in a demo afterwards. Once we have the attribute, we can go to the next parts. So the next part that you will need to have is a configuration provider. And as you can see, this is implementing the iExtension config provider, which is coming from the WebJobs runtime. And you need to specify the attribute for that extension name. This name that you put in here is used basically in your function JSON to tell the function's runtime which binding to load and to use. Especially if you are doing C# script functions and not full framework functions, or if you're working with a node function, you have to function JSON that describes what bindings need to be part of the host runtime. So the iExtension config provider defines only this method, which is called initialize, where you initialize your binding. You get a context. From the context, you can do things like the add binding rule, add to input, bind to input, bind to collector. Basically, these are the two types for binding an output and input binding. Add binding rule tells the binding what attribute is used. And when we look into our binding rule, so apart from the bind to input, bind to input, and bind to collector, we also have, sorry for that, we also have, as you can see here, try to zoom in, we have also the add validator. So if you want to add a validator, you can use add validator. At this point, add validator has gives you an action, so you have an action that then tells it what to do or where to start. We also have, after that, when you add the validator, you also can basically add a standard stream input. So this is then called whenever the user is asking for a stream. You can bind to a stream. Best is you get familiar with this and you try out and see for yourself what you need to use there. For now, we talked about that we want to have a SQLite binding. So we will basically bind to an input provider that is binding to SQLite, and then we will have an output provider that is writing to SQLite. As you can see here, we need to define the type that is coming back, so our own type. For that, I have in my models, I have a type that is called tag, and tag has just the tag string as a property and nothing else. So when we add here tag, we can then just bind to tag. Right now, it is giving me the errors because the inputs the input async converter doesn't support or doesn't have tag right now in there. Once you fix that, all of this is gone. And for the output, we also bind to tag. We will talk about the converters in a minute. Let's first look into our input converter. We also have here an interface that's called iAsync converter. If you don't want to do async, you can also just use iConverter, which works too. The iAsync converter basically defines that interface basically defines only the signature, where you get your configuration, and you basically have to return that type. So we said our type is tag. We go for tag again. Then what we say is we are basically giving back a tag for now, just now. Then when we look in our basically in our output collector, here we have the same thing. We have an interface, and we need to tell the interface what type we support. There we go. And then we need to implement basically two methods. One of the two is called add async and one is called flush async. So here's the thing about the output bindings. It is not that well documented and it is not that well lived by all the extensions that are available for Azure Functions. For example, some extensions don't comply with the rule why we have a flush async and add async. The idea is that you can use add async and add stuff, and if the function fails, flush async will never be called, and if the function completes, the runtime, the host runtime is calling flush async. So you can have kind of a transactional way to do things. So if we wanted to support this, let's say for now we just create a list of tag, right, and we call it transaction, and then we can, for example, do add data and return a task completed. So, and then once it is done, we can do here our flush async, which is then writing it all to the stream. Okay, so now we have our two converters for input and output bindings done. Collectors. So for now, if we just use this without all the converters here, we can basically just use our binding, but only with tag as a supported type. Let me compile and see if there's something missing. I guess, yeah, there is something missing. Yeah, we have some more. That's fine. We'll get to the converters in a bit. Let's have a look into how we can get this all, because now we need to tell Azure Functions host runtime that we have a binding that is supported. And as you remember, we use this interface to create a config provider for our binding. Now we need to tell the functions runtimes how to create our provider. And for that, we have an extension method basically that says add that is called because this is set up as in the assembly. So we define on the assembly web job startup. We have this type, and then the host runtime is going to look for this type. And we have an interface that's called web job startup that will give us a configure method where we can, as you know, as you probably have seen this in the new ASP.NET Core and generic host parts of .NET 5. We get a builder where we can use dependency injection to inject stuff. So I wrote my own extension method that is basically taking the builder, and then on the builder we can just here go say builder dot add extension, and then we can give it our config provider. As you can see, it is expecting an iExtension config provider. So we take our config provider and just add this. And now the functions runtime knows our config provider and knows our type. Great. Now we have our basic function, and if we just run it, it will work and everything should be fine. Let's comment these parts out. And these out. And also these out. And then let's build our package. So what we missing? Oh, I commented. Yeah. Okay, Once everything is done and right, you can see here we have an extension created, and is then just a NuGet package, so we could just upload to NuGet and then use it from there. Or for now, we will just use it from the source here. And you will increase the version number to 1.0. Go ahead, and then we'll just go to Visual Studio, create a new project. An Azure Functions project. We'll call it function 1, doesn't matter. And go ahead and say we used an HTTP trigger. I will use the storage account. And there we go. If you have done Azure Functions, you are probably familiar with this. So this is a regular C# function. There's HTTP triggered, and now we want to bring in our own binding. So when we add a NuGet package, I can go to the SQLite one that we just created. No, rows here. And then we said 01001, install it. We say yes, it's okay. Now at this point we have our binding available by just going SQLite and adding the right namespace. It is right there, as you can see. And now we need to specify the our configuration. For the connection string, for example, we have connection string is SQLite. As you probably will remember, I told you that the configuration that we set here is set to app settings. So we specify just the name here, and then we go to our local settings. And at this point, we add the SQLite and then tell him data source equals my test db.db. And now the host runtime is going and grabbing it from the app settings. Now we need to define what we will support. So let's say this is an input binding, right? If this is an input binding, then basically what we will have is here something that says tag, because we only support tag so far, and say tag. So what happens then is the host runtime is going to our code, going to the input async converter, and then basically just calling this line with the attribute given. And he would do the connection to the SQLite database and then just return whatever we wanted there. So, but there could also be that we want to support a list of tags that is coming in. For that, we need then a converter or to bind to the type list of tag. For now, we will just stay with the tag, and then we will do another binding, SQLite, connection string, same thing, SQLite, CS, and this one is an async collector of tag. So, and this is our out tags. So now that we have those two, we can work with them and we can basically just use them. I will just change that code to check for tag.tagString, and if it is null or empty, then basically call this line. If it is not null or empty, then say hello text string, whatever. Great. Now, if you run this, it will fail and it will throw an exception, because right now for tag, we're just returning null. To see it in action, what we will do is, instead of returning null, we will return a new tag and set the tag string to Gen 2021. And we'll number, redeploy, and here we'll update dependency to the new update number, version number, and then we just go start. As you can see, our function runtime is starting up. I will just use the browser and just call it. And as you can see, it is going in there and, oh yeah, sorry for that. And it says, hello, CloudGen 2021. So now let's say we want to debug stuff and we want to find out what is wrong and what is not working. So basically what we can do is we can go into our binding and then we can do a little trick. We can go here and say debugger dot break. And then basically the debugger will break and we can check here what is happening. And we will also add now, for now, just the debugger here. Break. And here too. So we can see when something is called. Now we'll go to this guy, increase the version number. Yeah, you have to increase the version number just because .NET thinks, oh, I already have that version. I don't need to update the assemblies, and then it might not work. Okay, now going back to our functions, we can just run it again, and this time the debugger will break, hopefully. So call it, did not break. And this is something that happens from time to time if functions thinks, okay, I don't need to update anything. Let me check again. 1.2. Oh, I didn't update dependencies, did I? No, I did not. There's 1.2 update. Okay, this is why you need to update the version number. This is basically what happens if you don't. Good example. And now we have this running, and you will go in there, and as you can see, the debugger is breaking, so we can see what is coming in. We have our config, and we basically return that. And then the debugger is called, as you can see, again on flush async, because we have this output binding. So let's go to our function. Let's say we want to add things to our output binding. So this is what we do here is we await for out tags to add async. And we just add new tag, tag string of. We'll just add new GUIDs to it. And we can do a bunch of these, let's say 3. Now, the interesting part is when is add async is called and when the actual function is called. So we'll have another breakpoint on the return time, and we will start this. And I will just move over the screen so we can see the code and how it's behaving. So I'll refresh now the call. I will call the function again. As you can see, we are now in the converter, right? So we are starting on our input byte. We go on this, and now add async is called. This is basically our call here, the first one. Now add async is called again, add async is called again. We are now on the third call, and now when we go on, usually what people expect is that flush async is called. But as you can see here, first the last line of the function is called, so you make sure that it is even the last line is completing. Once it is done, flush async is called. So now I have kind of a transactional behavior. I can make sure that everything is fine, the function completes without errors, and now I can write to the data sync. Okay, so that's nice, and this is how bindings work. But let's look into converters. As I said, converters are very, very powerful. They basically make everything nicer. I have usually what I do on my bindings, I add some common converters, right? And I have then an extension method that is adding all of those. So let's call this add all tag converters, and then we go into the common converter, comment this, and call it add all tag converters. So we will remove the dynamic part because dynamic is no longer supported in the new versions. And then we basically just replace my data type with tag. And then we will go through this and see what it actually does. Okay, so basically these converters that I have created here, what they do is they add a conversion from string to tag. So basically how we do string to tag is either we just create a new tag. For example, if I want to say, okay, we have on our tag, we have our tag string, and whenever someone says as an input binding, I want a string, he is expecting the tag string, not the tag as a string. So not a serialized version. So let's do this by just returning. So when we get a string, we just return a new tag with tag string set to the value that we get. Great. Then we have converters for JObject. This is very, very important that you have converters for JObject because everything that is basically just serialized down to a runner, a node runner, is using JObject as the type to expect. Then we have expander object if this is needed. Then we have from tag. So on our output way, if we get from the node runner our results, it comes as JObject, and we need to create tags from that. So we can use just JObject from object, which will just deserialize it to a tag. Then we have the other way around. We talked about this, and this is then tag string. So he's expecting a string and gets a tag. And then this is basically it. So these common converters make sure that you at least have support for string and JObject and all the JSON stuff. Now another thing that we could add is we could also add, let's say, we want to support streams. We could add stream to tag converter. This would then basically just take the same things here, and that would then, so we get a stream. We expect the stream to be something like an let's say it is going to be an UTF-8 byte array, so we need to convert that. So context dot add converter from stream tag, and then we need to implement a function that is basically taking in a stream and then giving back a tag. So in create a new tag, and we'll make it just very, very simple. We go encoding dot dot get string, and then we have our stream where we get we would then read all data. So we need something that is converting our stream to a byte array, right? And because we want to use async, we usually would do this with an async converter. Okay, this was a bad example. I'll take it out for now. But this is basically how you add new types. Once this is done, we can just go to our solution, increase the version number, and rebuild it. And then go back to our function, update the dependency. And now we have support for string. So instead of tag, we can just go string here, and then we just can take our tag without adding anything. So everything else is done by the function runtime, host runtime, and it is just calling our converter. So we start this. And we call function, go through our debuggers. As you can see, it just converted. So it just works. So by adding those converters, I can support data types that I don't need to fully implement. I just need to implement how they convert from the type that the user is asking for to the type that I have the implementation for in my code. Now, another thing that I said is we can work with open types. So open types are very interesting. The idea is that instead of saying string and instead of for us to know what the user is asking for, the user could just add his own data type, test tag. And this one would, let's make it simple. This one has also tag string. This it is called awesome tag string, right? And set. Now he wants to use, instead of tag, he wants to use test tag. Now, how are we going to support this? This is kind of tricky because we don't know how the data type is going to look like that a user is calling. So usually when you would do this is, let's say you're working with Cosmos DB, and Cosmos DB, you can have documents in there, and your documents can have types. So the user usually knows what type is going to be available on the other side. So now in this point, we'll expect the user to know what the type is, and we will also add test tag here. So instead of new tag, he can then basically just go new test tag and use the awesome string instead. Okay. Okay. Now we need to figure out for ourselves how we are going to support something like that. For our tag type, we can use a small trick. Basically, when we use our tag type and then we have an open converter, so the user is converting to something we don't know, we need to implement the two parts, from and to converters, right? So our from converter, that is taking tag and returns whatever type the user asks for. And we also have a support for list. So the user wants a list of those. And what we will do is when we return a T and we get a tag, so the user is actually loading data, so an input binding is involved, we will deserialize whatever is in the tag string. Sorry, put doesn't have link. I dot tag string, right? And on the other hand, if we are converting to the other side, so we get a T and we want to make it a tag, we basically just go and add and serialize it to our tag string, right? So the serialized object, the tag that it will return is a new tag, and tag string will have our tag string. Same here, new tag, and tag string equals the serialized option of I. And now when we add these to our config provider, these types, and as you can see here, I have the regular type and the list types here. And you will increase the version number to 4, compile it. It's failing because I forgot something. Oh yeah, we need to deserialize. We need to deserialize to T. Okay, now we compile this, and then when we go back to our function, so basically now we support test tag, even though we don't, in our binding, we don't know test tag at all. So if we just run this, everything should work, I hope. We basically, oh, sorry for that. We basically can call a function, and it is failing. So there is something. Okay, he's not able to bind to this. Because our open types didn't bind right. Anyhow, the time is short. All this and the solution of this and other things are on my GitHub, so you can look it up there. Sorry for the last demo that didn't work, but this is basically the concept how bindings work. Now, I want to point out that there are some dependencies or some bindings that I've created already. So if you're looking, for example, something to bind to key vault, let's say you want to do some encryption and decryption using the key vault, save secrets, read secrets, and so on and so forth. I have created a function binding for that. You can just use it by just adding the NuGet package and then just using it right away. It basically supports all possible key types, algorithms, and so on and so forth that are supported by Key Vault, and you can just use them. Another thing that I want to point out. So I have created, as I said, I've created an template. So you can look into a template when you want to start with your own, and you need to replace obviously all the parts that are your bindings, but comes basically with almost everything that we saw in the demo right now, except for you also need to define your attribute, right? That is not there yet. But you can find all of this on GitHub, and I will have a link for you where to find those and where to find the documentation at the end of the presentation. Now, I want to also ask, answer questions. So far, we have one in the chat, and Marco is asking if Azure Functions support .NET 5. Not yet. The host runtime does not support .NET 5 yet. Also, bindings need to be in .NET Standard 2.0, so until .NET 5 is supported. But as I said, there is a .NET runner basically being created right now that is out of prod, that will then also run on .NET 5. So you can run your .NET 5 code on the .NET 5 runner once it is available. You can go to the GitHub repo, download and use it yourself, and see for yourself if this is something that you want to start working with. It is not yet stable. There are a lot of issues still open, but it is interesting to follow this and to see how it's going. Okay, I'll just switch back to slides. Just to go to the thank you slide, because this is the most important part. All these links, I know it's hard because they're long links. I have them all together in a gist, and you can just take a photo of the QR code, and there you should get to the gist and get all the things that are needed. Do we have any more questions? I'll wait a minute for questions to come in. Okay, it doesn't look like there are questions, so basically, if you have questions, just shoot me a message on Twitter, reach out to me, hopefully I can help you. And if you like to know more about how functions, how the runtime works underneath, it is all open source. Go to the project, check it out, try it out. It's the best way to find out. And if there's something, I had it once or twice that there was something where I couldn't understand what the problem was, by checking out the functions runtimes repo and starting your function on the runtime instead of using that CLI runner, you basically can even debug into functions and see what is the problem there. So for the problem that we had, that he isn't recognizing my open types, now we'll just start the runtime host and see what the problem is, why he is not finding the open types and why he can't bind to it. Okay, I hope this presentation was interesting to you. And as I said, if you have any more questions, just reach out. Thank you, Marco, and thank you everyone for hosting this event. Thank you, CloudGen. I hope you all enjoyed it. Have a great day, stay safe, and make sure everyone in your area is fine. Thank you.